Alright guys, so something we've done in class recently was this group work exercise where we had to graph some quadratic functions. So many of your groups would come up and send your resource manager up, and I would give you a function like this. So here we go, y equals negative x squared plus 4. Now we know from our unit before that this thing is definitely a quadratic function because it has that x squared. So your task was to take a function like this and use your calculator to graph it, and then you were asked a series of questions about the parabola, which is what we call the graph of a quadratic. So like the first question was, how would you describe the shape of the parabola? Would you describe it as opening up or down? Did the sides ever go straight up vertically? Why or why not? Is there anything special? So questions like that. So really you guys just had to graph this thing and then just talk about all the special things about it. So what I have up here is a bunch of different graphs that the Lions did that I thought would be helpful for us to kind of see and compare some of the different graphs. Alright, so here's some of our different graphs that we had from the Lions. So you can see there's definitely some similarities here, definitely some differences. So why don't we take a second, we'll look at each one, and then we'll kind of talk about how some of these are similar and different. Alright, so here is our first one. Okay, so here we go. Looks like they made an edit on their graph. I think one of the points was plotted incorrectly and they fixed that. Kind of see this. So something they talk about was the shape. It looks like a U and it's opening down and it's going straight and it will never stop. And then they say it has or there's something about line of symmetry. They didn't have enough time to finish that, so just to kind of add to that, we can kind of see some of the special things. Is yeah, this thing definitely opens down. So somebody said it kind of looks like a mountain. I agree with that. Some other important things to kind of notice about this is it's got, one x-intercept over here, which sometimes we call a root. And I think the way in which this was scaled, so I believe this would be at -2, right? And then they have another root over here, which I believe is at 8 from the way that's scaled. And then we could also see that it has this axis of symmetry over here, going straight through there, cutting the parabola in half. Okay, and this one was actually kind of hard for this team to identify what the vertex was, because you have this, and then where the vertex actually fell for this one, I believe, was in between 2 points. So I'm not sure if they were ever able to identify that. By the way, the vocab word vertex, that's the highest or the lowest point of the graph. Let's take a look at another graph now. So here is another one. See that this one's a little bit different from the one that we just saw. So let's see what these guys say. So the shape of the parabola would be opening up. That's definitely true. It's opening up, and the sides of the parabola would be going vertically because the lines aren't going straight. Something about this shape is its coordinates 2, 1, 0, 5, and parabola does have a line of symmetry. If you fold the graph up to the right, it would match. Okay, yeah. So a lot of great stuff here. There's some stuff about it going up, some talk about vertical and then it going up straight. They do state, though, that this thing is not going straight, which is true. You can see that no matter what, it's always going to be going a little bit to the right here and a little bit to the left over here. Okay, it should never be going straight up. They also identified some of those critical points. So one was 2, 1, which is over here. So that's what we call the vertex. That's the lowest point, okay? And they also identify this, which is 0, 5, which is our y-intercept. One thing that's interesting about this graph is this one doesn't have any x-intercepts, or roots as we call it. That means it never touches the x-axis. Okay, so you can see the lowest point right here is still in the first quadrant. It never touches that x-axis. So that's definitely something that's interesting about this graph. They also state that it has a line of symmetry, and they mention this word folding. I kind of like that because if we draw the line of symmetry, I'm using my left hand, it's not going to be perfect, but you could kind of see that, yeah, you can fold the paper and it'll be the same thing on both sides. That's a good way to think about line of symmetry. All right, so let's take a look at this group now. Interesting way of scaling it. Looks like they scaled the y-axis going up by 3s, x-axis going up by 1s. Okay. We can see we still have that U shape over here. Now let's see what these guys were talking about. So the shape of the parabola, it makes a U, and I would describe it as opening up. It will go straight up, but it got wider. So I think that's similar to what the other group is saying. So this thing is going to get wider, or I don't know if that's the word I would use, but they have the arrow. It's definitely pointing out this way, so we're kind of noticing that this thing should never be going straight up. Let's see what else they're kind of saying. So yes, the parabola has a line of symmetry, and yes, the sides match with each other. So that's that folding idea. It works for all parabolas because the shape will always make a U, which always has a line of symmetry. Yeah, if you draw a picture of a U is always going to have a line of symmetry, so that's kind of an interesting observation about all parabolas. And what else do we have? Yes, there is some special points on my parabola, which is 1, 0 and -1, 1. These points are important because -1, 1 is crossing the y-axis, and 1, 0 is the starting point. So let's take a look. Yep. So 0, 1, that definitely is crossing the y-axis, so we call that a y-intercept. And then we also have this point of 1, 0. Now, they call that a starting point, and I don't necessarily know if I would call it that. You could call it a turning point. That's one thing you could call it, because from here going down, we're decreasing, decreasing, decreasing. We hit that point, and then all of a sudden we're increasing. Okay? But the vocab word for that would be vertex, and in this graph, that is the lowest point. All right? So yeah, so we have this right here. And then again, they also mention that line of symmetry. So again, we have that line of symmetry going through here. And yep, we can kind of see what their function was. So that's what they were graphing. We could also see something else that's interesting where it has a vertex that happens to also be your x-intercept or your root. So those are the same thing. So where the vertex is where it happens to touch the x-axis. So that's something that's pretty interesting about this group's graph. Okay, so now our last one. Here we go. So another graph. I believe that this one is actually the same one we just looked at, but just scaled a little bit different. And then, yeah, actually that's interesting. So yeah, it is. So if we look at the function, it's x squared, y equals x squared minus 2x plus 1. And then the one that we just looked at is also y equals x squared minus 2x plus 1. And you could kind of see the same things here. So again, it has that y-intercept at 0, 1, and it also has that vertex, or what we call the root, or what we call the x-intercept at 1, 0. Okay? So similar things we're seeing, the same things we're seeing. And you can kind of just see like how the scaling can kind of affect the graph. So the way that this student had scaled it looks a little bit more narrow, right? And then the way that this group had scaled it, you get kind of a wider, deceptively wider looking graph, all right? But regardless of how they graphed it, we were able to kind of make the same observations. Okay, so what you should do now is, now that we've seen all these different graphs, why don't we call this first one, we'll call this graph A. We'll call this second one that we looked at, this will be graph B. Call this one graph C. And then this was the same one, so we'll also call this graph C as well, okay? So what you guys could do now is, in the comments section, is looking at these 3 different graphs. Tell me how many differences you noticed between them and how many similarities you noticed. So again, if you're going to leave a comment on this one, how are the graphs different? how are the graphs similar, okay? We'll go around and just take a look at each one more time. And that's really it for this one, guys. So again, leave a comment for the differences and similarities. If you have any questions, feel free to ask, and have a good one.